In the 1960s, the dream of a generation comes true.
The Eagle has landed.
Human beings walk on another world. Arriving there in an incredible spacecraft, the lunar module.
It looks like something that came from outer space. It turned out to be a bug.
Creating the lunar module is the ultimate engineering challenge.
If your ascent engine doesn't work, you're dead. Simple as that.
It takes ingenuity and dogged determination.
The technology we had was crude compared to what exists today.
There was always difficulties and problems.
From risking lives on Earth to saving lives in space. This is the story of the unsung heroes who built the world's first spacecraft to land humans on the moon.
It's one small step for man, one giant leap for mankind.
The lunar module is an engineering marvel. The ultimate Winnebago, made from 48 kilometers of electrical wiring, 500,000 rivets, and ultra-lightweight skin not much thicker than kitchen foil. It may look an unconventional flying machine, but it's the culmination of millions of man-hours of engineering prowess.
It was ugly, but it was beautiful in the fact that it was not an ounce was wasted. It's all form follows function.
Between 1969 and 1972, the lunar modules carried 12 Americans to the moon's surface on 6 Apollo missions. They are the spacecraft that make the dream of a generation come true.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
May 1961. Spurred on by the Cold War, President Kennedy delivers to NASA a seemingly impossible engineering challenge: to land the first men on the moon. At the time, Glyn Lunney is a young engineer at NASA.
We were thinking, wow, that is really an incredible goal to set. And our minds immediately turned to, how are we going to do that?
It's all the more incredible as America's only spaceflight experience happens just weeks before the president's announcement.
We just barely got Al Shepard up, and he flew a couple hundred miles in the air and came down.
Astronaut Alan Shepard's short suborbital hop lasts just 15 minutes. Now the goal lies 386,000 kilometers away. Kennedy's dream inspires some of America's brightest young engineers, like Marty Finkelman
Nobody knew for sure whether we could do it.
and Stephen Rocambole.
Everybody in the world was looking, what are the Americans doing?
Before anyone can set to work, NASA must make a critical choice. What's the simplest and most achievable way of flying to the moon?
When the problem of landing on the moon really became serious and they had to look at it, the natural assumption is, look, it's right there, let's just go there and land.
This no-nonsense approach uses one giant rocket in a method dubbed direct ascent. The rocket must be powerful enough to carry everything needed to reach the moon, including a big, heavy spacecraft over 21 meters tall that lands on the lunar surface and then lifts off again to fly back to Earth. But as engineers like Jerry Sandler are quick to point out, direct ascent has a major flaw.
Direct ascent required a great deal of thrust
and a booster larger than anything we could have even imagined at that time.
Building a rocket this large and powerful is likely to make Kennedy's deadline impossible. NASA needs an alternative solution. They explore a riskier method called Earth Orbit Rendezvous. This requires not one new giant rocket, but two smaller rockets, each launching part of a spacecraft to be assembled in Earth orbit. But two rockets means double the risk of a failure at launch. NASA must make a decision quickly. Enter young aerospace engineer John Hubolt. He's working on a radical idea. So radical, it hasn't been given the attention it deserves.
John Hubolt was the guy who said, look, you guys aren't thinking about this properly. Every time I brought this in front of you, I've been dismissed.
Hubolt rejects direct ascent and Earth orbit rendezvous in favor of a more swiftly achievable method of getting to the moon. His unpopular idea is called Lunar Orbit Rendezvous, or LOR. It uses two small spacecraft. One, called the Lunar Module, descends to the moon's surface, while the other, called the Command and Service Module, remains in lunar orbit. Once the astronauts have finished on the moon, the top stage of the Lunar Module returns them to rendezvous with the Command Module before it's discarded. To Hubolt, the advantages of LOR are obvious.
You need one less launcher, you don't need the giant impossible rocket, and you can dedicate the lunar lander to do the one function, this difficult thing that we've never done before, landing on the moon.
But for NASA, LOR has a nightmare scenario.
Lunar Orbit Rendezvous was very scary, because if you miss the rendezvous, if this little ballet of spacecraft trying to join up doesn't work, you're dead.
But Hubolt isn't discouraged. He gambles his career by going straight to the top. He writes a letter to one of NASA's senior executives.
I fully realize that contacting you in this manner is somewhat unorthodox.
Hubolt goes on to lambast his managers for dismissing LOR. His conviction's evident in a copy of his letter.
Wow, this is amazing. Yeah, you see this? I've been appalled at the thinking of individuals and committees on these matters.
Hubolt lays it on the line and bluntly asks,
Do we want to get to the moon or not?
I would say this letter saved NASA from failure of landing on the moon in time.
As the clock ticks, NASA engineers finally accept the LOR method. And on July the 11th, 1962, they announce their decision. Over a year since Kennedy's speech, NASA is ready to choose a contractor to build the lunar lander and reach for the moon. One company stands out: the aircraft manufacturer Grumman. In November 1962, they win the bid. But planning the lunar mission has cost precious time. Grumman engineers will feel the heat, spending the rest of the decade racing to get to the moon. A year and a half since Kennedy's promise to land men on the moon, Grumman engineers must turn their design for the lunar lander into a reality. They have a sterling record in constructing commercial planes and fighter jets. But now they face one of the greatest challenges in aviation history: engineering a machine that flies not on Earth, but in space. The engineer's initial inspiration comes from a familiar flying machine on Earth.
The winning design was kind of like a helicopter with little legs. And the little legs were small and they had little pads.
Grumman's lunar lander seizes on the design of the helicopter for one critical reason. The astronauts must be able to search for a safe place to land. Almost nothing is known about the lunar surface, other than it will be unforgiving and treacherous. A young pioneering rocket scientist, Gerard Elverum, would be crucial in finding a solution.
There were a lot of speculation about what the surface of the moon was, whether there was 6 feet of dust up on the moon or whether it was a few inches.
Engineers know it's going to be dangerous. They need to predict how the lunar module will react on touchdown and design everything to prevent a crash landing, which would leave the astronauts stranded on the moon to die. Engineers must help avert this worst-case scenario.
Being able to hover and spend some time finding where you wanted to sit down became very important.
The astronauts practice in this, a NASA test vehicle dubbed the Flying Bedstead. It's inherently dangerous. Elverum is challenged with designing a way to allow the astronauts to maneuver while descending to the moon's surface. His solution is to devise a spacecraft engine that can throttle.
It was brand new technology. So these 2 valves here controlled the flow rate coming from the tanks in the descent stage.
By controlling the supply of propellant to the descent engine, the astronauts can control its thrust, allowing them to maneuver like a helicopter. But landing safely on the moon is only half the problem. The other half is building an engine to get them off the moon. It would be known as the ascent engine.
The problem with the ascent engine, the difficulty was that it had to work every time. That's a single point of failure. If your ascent engine doesn't work, you're dead. Simple as that.
Like the descent engine, the ascent engine must be as simple and reliable as possible. Fresh out of college with a degree in aeronautical engineering, Tim Harmon is tasked with the challenge.
We had to keep it simple, and NASA realized that as well. Not a lot of complexity.
Keeping it simple means stripping out as many moving parts as possible. Pumps, valves, and turbines. But the engineers then face another challenge. If you rip the heart out of a rocket engine, how do you get it to fire? The answer lies with the fuel itself.
You use propellants that don't need an igniter, that don't need a turbine, a bunch of moving parts to suck them in and then burn them.
There are certain combinations of propellants that if you mix them, they automatically ignite.
One look at each other and they explode on contact.
It's pure simplicity. Push the 2 propellants together in the engine's combustion chamber and bang. But using these self-igniting fuels comes at a cost. They're so corrosive that at the end of a test, each engine has to be rebuilt. It means the final assembly of an engine can never be tested.
They'd build an engine and they would take it out to a facility that we had in White Sands, New Mexico, and they would fire the engine up. Now, after they fired the engine up, they would take the entire engine apart and clean it and reassemble it. That engine would not be refired again until it was on the mission.
So when the astronauts use the ascent engine, they'll be gambling with their lives. These two engines control the two-part lunar lander. The descent stage, with its throttling engine, flies the astronauts to a soft lunar landing. And the ascent stage launches them safely back into lunar orbit. But Grumman's design is still in its infancy. As they begin to build, they soon start battling against every space engineer's enemy: weight. Like the astronauts, the lunar module will be carried into space by NASA's mighty Saturn V rocket. But there's only so much it can lift. The problem is, the lunar module keeps getting heavier.
The weight started to climb. We went 20,000 pounds, we went 22,000 pounds, 24,000 pounds. It was a constant battle.
By October 1964, the LEM's weight has ballooned to a crippling level.
Whenever you went to work, even if you made a change, everybody was saying, well, what's the implication for weight? It was there all the time.
The LEM being overweight late in the program generated what I would call a bit of a panic.
Something has to give. So Grumman wages an all-out war on weight. Engineers start by shaving off every spare ounce of metal.
We would be paid $40,000 a pound for every pound of material that we could scrape off.
Every part of the lunar module's design is then reassessed.
You wanted to have great visibility, so they had big windows. Now, glass is very, very heavy.
The large windows are replaced with smaller, lighter ones. But now the seated astronauts can't see where to land.
Somebody came up with the brilliant idea, why don't we just put restraints on the crew and have them stand up facing the window and leaning over and get the same angles.
While descending to the moon, flying sitting down or standing up makes little difference. It's an ingenious weight-saving idea. Engineers must then find the lightest materials possible for every part of the lunar module.
The astronauts lived inside this air balloon made of metal, and this is the thickness of that balloon. The astronauts would be on this side, where there was oxygen. On this side was the deadly vacuum of space. 12 thousandths of an inch thick is all that was.
In all, the engineers shave off more than 900 kilograms and transform the appearance of their lunar lander. Gone are the helicopter-like windows and seats. 5 legs become 4. The circular hatch becomes square. Heavy panels are replaced with facets of thin aluminium. By 1967, Grumman has their spacecraft. But it hasn't even left the workshop. When it does, the pressure on the engineers skyrockets. June 1967, the first lunar module, LEM-1, arrives at the Kennedy Space Center in Florida. It's already months behind schedule. And before it can fly, the lunar module must pass NASA's stringent tests to see if it can keep 2 astronauts alive in the moon's lethal environment.
When the LEM goes down to Cape Kennedy, you know what the first thing they do? They take it apart. Everything gets taken apart.
What they find is a disaster for the Grumman engineers. The welds on LEM-1's fuel tanks and fuel lines have a critical problem.
They opened it up. They tested it for leaks. It leaked like a sieve. They couldn't believe how badly it leaked.
The tank's welds are riddled with microscopic holes. Grumman thought their welds were up to standard, but NASA's tests are more rigorous. Unsafe to fly, the lunar module is grounded.
Well, it certainly causes embarrassment, and to have a setback like that is serious.
The weld repairs take the engineers 3 months, delaying LEM 1's flight further. Meanwhile, back at Grumman in New York, another crisis throws the schedule into disarray. It happens towards the end of 1967, during a pressure test.
In December, lunar module number 5, Eagle, the first one to land on the moon, its window blew out during a standard test. This was completely unexpected.
I hear the LEM has had a window failure. Oh my God, had a window failure. Right away I said, that would cause an astronaut to die.
The window has a critical flaw, which was missed in the inspection. But the broken glass also poses a major threat.
There's plexiglass and glass all over the interior of the LEM. I could see wires cut, nicked.
A single shard could short-circuit the LEM's electrics, or worse, severely injure an astronaut if it's inhaled.
And I am overwhelmed. I'm going, oh my God, what are we going to do? I said, should we scrap it?
But Grumman knows that scrapping a multi-million-dollar spacecraft simply isn't an option. Instead, they have no choice but to try and save LEM 5. So NASA implements a meticulous cleanup job. And young engineer Steve Rocamboli is on the front line.
We could not even see what we were cleaning at times. There were people with camel hair brushes and filter paper, and they would go like this and collect particles on the filter paper that was sent to a quality lab where our inspectors would count the number of particles and the size of the particles.
NASA's criteria for cleanliness is agonizingly stringent. First, every inch of the spacecraft is photographed in detail. Then, every fragment of glass collected from each photographed area is removed from the lunar module, placed under a microscope, and precisely measured.
If you had so many particles of a certain size and density, then it would be a problem.
After a 3-month cleanup, NASA finally declares the lunar module is safe for its astronauts. As Kennedy's deadline bears down, the milestones come thick and fast for the engineers. The millions of hours they have spent on the lunar module begin to pay off. In March 1969, Grumman's spacecraft is finally ready for its first manned test flight.
The engines are on. 4, 3, 2, 1, 0. We have connected. We have
Apollo 9 blasts off with 3 astronauts on board. In Earth orbit, the bug-like spacecraft practices undocking and docking with the command module.
Okay, I have it about 370 feet. Okay.
The test is a complete success. 2 months later, Apollo 10 takes the lunar module even further. This time descending to within 14 kilometers of the moon.
Oh, very pretty.
Now it's time to head all the way to the moon's surface. On July the 16th, 1969, Apollo 11 thunders skyward from Cape Kennedy.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
4 days later, in lunar orbit, Apollo 11's crew powers up the 5th lunar module, Eagle, ready for its descent to the surface.
Go for undocking. Roger, Eagle, undock. Roger, how does it look? Go ahead, please. Right. We go aft Tommy, over.
After 7 long years, this is the opportunity for the engineers to beat Kennedy's deadline. Now their spacecraft must carry 2 astronauts on humanity's most dangerous journey.
I was concerned about everything. The money was on the line now. We were going to the moon.
Their worries are well-founded. Eagle's flight will be far from plain sailing. July the 20th, 1969. Astronauts Neil Armstrong and Edwin Buzz Aldrin begin man's first journey to the moon's surface. Aboard their lunar module, called Eagle. Now it's crunch time for the engineers who built it.
You got a fine-looking flying machine there, Eagle.
Will Eagle withstand a lunar landing?
Okay, everybody, let's hang tight and look for landing radar.
The mission hinges on a computer to guide them down to the lunar surface. But it has just 1 megahertz of computing speed, over 1,000 times slower than a smartphone. Such a small amount of processing speed could prove a showstopper.
Program alarm. 1202 alarm.
1202 is a computer alarm. Neither astronauts nor most in mission control have a clue how it will interfere with the lunar landing, including flight director Glyn Lunny.
Oh, yes. I mean, it caused a lot of concern to people because they all knew that it was a risk to the landing. They had to decide whether to continue and land or whether they had to abort.
They're within just 12,000 meters of the surface. But everything the engineers have worked for hangs in the balance. One navigation engineer, Jack Garman, knows what the 1202 alarm means. He's seen it before in a simulation landing.
What it amounted to was the computer was issuing an alarm that says, you are asking me to do too much. You have overloaded me, the small computer.
There's no way of rebooting the computer to cancel the alarm. The question is, can the computer keep up and navigate a landing? If not, they must abort the mission.
Give us a reading on the 1202 program alarm.
Jack Garman is looking down at his little cheat sheet and he realizes that this alarm problem is one that cropped up unsuspectedly earlier on in one of their test training places and realizes, oh, we can still keep flying as long as it's this alarm.
Jack Garman said, ignore the alarms, everything is okay, the vehicle is safe to land.
We're going that flight.
Jack Garman and the other young engineers save the astronauts from a last-minute abort.
Eagle, Houston, you're a go for landing, over.
Apollo 11 is back on track.
Go for landing.
The fragile spacecraft closes in on the lunar surface. But heart rates in Houston are about to rocket once again.
As they looked at where they were supposed to land, they found that the whole terrain was filled with boulders and rocks.
So Armstrong makes a crucial decision. He accelerates and flies horizontally to clear the boulder field, using up precious fuel.
Descent to fuel only, no critical.
Eagle's fuel gauge is critically low. But incredibly, unbeknownst to both astronauts and mission control, the fuel readings they're seeing don't match what's actually left in Eagle's tank. It all comes down to something called fuel slosh.
Fuel slosh was an unexpected problem on the spacecraft. Because the tanks are round at the bottom and the spacecraft is moving around, the propellant is doing this kind of stuff. And there's a little indicator at the bottom that gives them an idea of when they're at low level. On Apollo 11, because of the slosh, it was uncovered about almost 40 seconds early.
The indicators falsely show a low fuel level. But astronauts and mission control are unaware of the problem and in a race against time.
That's 40 seconds less time for Armstrong to find a place to land, which was crucial for him.
75 feet, good down a half, Arch.
Engineer Dick Wilde, monitoring the life support systems, sees the drama unfold.
A minute and a half remaining. A minute remaining. 30 seconds remaining. And the guys who were managing the fuel supply were jumping up and down, and one of them yelled out for everybody to hear, "Land the goddamn thing."
I was sitting back there saying, Armstrong, set it down, don't abort the thing.
20 feet down, 2.5. Picking up some dust. Okay, engine stop. ATA at a descent. We've had shutdown. We copy you down, Eagle. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Thank you.
They landed it with seconds of fuel remaining. That was excitement.
In reality, Armstrong has 40 seconds more fuel than everyone thinks. To the engineers, it seems the astronauts have just escaped certain death.
The feeling I had when it happened is, it's done. It never can be undone, you know. These are the first guys to land on another body from Earth, and you can't take that away from me, and it was my engine that allowed it to happen.
It's one small step for man, one giant leap for mankind.
A decade-long struggle for the lunar module engineers has finally paid off. But one engineer is still waiting with bated breath. Tom Moser designed the US flag for Apollo 11.
I didn't think it was a showstopper. I thought doing something like that was something that was pretty straightforward.
Moser has engineered a horizontal pole for the flag, designed to stop it hanging limp in the moon's zero atmosphere.
That rod had an improper coating on it, so it wouldn't extend all the way, so it looked like the flag was waving in the breeze.
The flag support pole is a little-known engineering failure and leads many to believe the whole mission is a conspiracy staged here on Earth.
There's no atmosphere, there's no wind up there, so how could it be waving? It wasn't waving, it was just, it was not able to unfurl all the way.
The astronauts explore the moon for just a few hours. Now comes the part engineers are secretly dreading. The moment the lunar module must help bring them safely home.
9, 8.
If the ascent engine doesn't work, they'll be stranded on the moon.
Engine arm ascent. Proceed.
They just calmly said, ignition, beautiful ride, everything was fine.
Beautiful. 26, 36 feet per second up. Very smooth. Very quiet ride.
And that was totally not adequate to express the engineers' relief at that moment. It was really a big deal.
Eagle Houston, the request manual start override.
It went flawlessly. When Apollo 11 lifted off from the moon, our job was over. Pride was probably the word.
I went outside and I looked up at the moon and I said, I have just witnessed history and I have been a part of history and I will never look at the moon the same way again. And to this day, that is still true.
Apollo 11's resounding success makes history. The lunar module has performed faultlessly. But its greatest test is yet to come, during the most epic drama in Apollo's history.
Stand by. Houston, we've had a problem. Stand by, 13, we're looking at it.
In April 1970, the lunar module is heading to the moon on Apollo 13. On board are astronauts Jim Lovell, Fred Hayes, and Jack Swigert. The goal is to explore the lunar highlands. But 56 hours in, Apollo 13 suffers a crippling explosion. Engineers in Houston, including flight director Glyn Lunny, face their nightmare scenario.
Somebody turned around to me and said, Glenn, you better get out there. When I got back in, all the panels had warning lights on them, and a lot of them were blinking red. I mean, it was like somebody turned everything upside down.
The service module is losing power and bleeding oxygen.
We are venting something out into space.
There is only one option: to abort the lunar landing and try to bring the astronauts safely home.
Now, we were 200,000 miles already out towards the moon, and so we knew we had to do things that we hadn't done before, or even tested before. We knew we had to use the LEM as a lifeboat.
We figure we've got about 15 minutes worth of power left in the command module.
With the command module out of action, the astronauts retreat into the attached lunar module, Aquarius.
So we want you to start getting over in the LEM and getting some power on that. And you ready to copy your procedure? Okay.
With its own oxygen and fuel supply, Aquarius is the crew's only hope of survival.
Confirmed ignition.
But whether the lunar module can save them, all comes down to the engineers. Immediately, they face a critical situation.
We knew that the life support consumables aboard the lunar module were really only designed to keep 2 astronauts alive for 50 hours. That defined our problem for us.
Now the lunar module must cope with 3 astronauts for 80 hours. The danger? The astronauts are slowly suffocating on their own exhaled carbon dioxide.
Everybody knew immediately that we had to figure out something to do about the carbon dioxide because we didn't have enough carbon dioxide scrubbers, filters, to last us all the way back in the lunar module.
One solution might be to use the CO2 scrubbers from the command module to filter the air in the lunar module. But there's a potentially deadly problem.
The kind of failure that occurred had not been forecast. Their canisters were square, ours were round. Typical square peg, round hole problem.
Only the ingenuity of the engineers on Earth can save the astronauts.
The engineering guys came on and said, Glenn, we already have a team of people working on that. We'll have an answer for you in several shifts.
In just a few hours, they must do the seemingly impossible. Engineer an adapter that lets the command module's square filter operate in the lunar module, replacing the spent cylindrical one. But they can only use equipment that's available to the astronauts. It's a huge challenge to improvise a low-tech solution and save the astronauts from asphyxiation. The engineer's design is ingenious. They use cardboard from reference manuals, plastic cut from a garment stowage bag, a spacesuit air hose, duct tape, and a sock.
I said, hey, this is going to work. This is going to work.
Swigert, Lovell, and Hayes assemble an identical version in space, with just hours to spare.
And all of a sudden, they see the levels start to come down. I said, wow.
The adapter is a triumph.
Very good. We felt exhilarated. We all loved the lunar module.
2 days later, when the astronauts splash down in the ocean, the engineers are elated.
Thank God 3 guys did not lose their life. It was nip and tuck all the way, but it worked.
I don't think I had a drink. I could have used one though.
The lunar module hasn't only performed far beyond its design limits, it has rescued the crew of Apollo 13 from certain death. In all, 6 lunar modules land 12 men on the moon. The last 3 each transport a lunar rover, allowing the astronauts to travel over 90 kilometers of the lunar surface. In total, they spend over 72 hours exploring this alien world. In 1972, Harrison Schmitt and Eugene Cernan are the last 2 astronauts on the moon.
May the spirit of peace in which we came be reflected in the lives of all mankind.
Humans haven't returned since then. But now scientists have the moon in their sights once again. In 2009, NASA launches an unmanned satellite called Lunar Reconnaissance Orbiter, or LRO. Carrying a high-resolution camera, LRO is revealing the moon in unprecedented detail. Exploiting resources at the lunar poles may offer challenges for future generations of engineers, as lunar scientist Paul Spudis believes.
One of the interesting things we found about the poles is it's sort of a unique environment. It has areas that are lit more than half of the lunar day. You can generate electrical power in order to create sustainable human presence on the moon.
Engineering giant solar panels would provide the power needed to build lunar bases. And mining water frozen in lunar rock could provide the hydrogen and oxygen fuels to propel future rockets, turning the moon into our first off-planet refueling station.
So we're going to the next step. We're going to sort of the exploration stage. Think of it as an early mining town.
While it's been mapping the moon, Lunar Reconnaissance Orbiter is also revealing remnants of Apollo's legacy, lying silently on the moon's surface.
I have 6 engines sitting on the moon. I wish I could see them, but I know they're all up there. They'll be there for 1 million years.
These are the indelible reminders of a generation of engineers who dared to explore another world and succeeded.